Hello students and welcome to this optional homework practice video. We're going to do a few of these examples just so you have some extra help before you start your assignment. And you'll want to have a graphing calculator available. So we're going to start with number 1. Y equals the square root of x minus 5, and we need to find the domain and range. So we're going to type in the square root. So right here, control, and then x squared to get square root, and then x. And notice the minus 5 is outside the square root, so press the right arrow, and then press minus 5. So we can look at our graph, and we'll do domain first. And we can see that our x value, in fact, if you go menu 5, 1, then you can see exactly what the numbers are. So we can see that our x's go from 0, and if I try to go negative, they become undefined. So I don't have any negatives. I go from 0 and up. And I'm just looking at x's, so 0 and up. So I can say that my x's go from 0 to positive infinity if I wanted interval notation. So 0 at the lowest end to infinity. Or I could also say 0 is less than or equal to x is less than infinity. So interval notation and inequality notation. And then my range so my lowest y value is negative 5. If I try to go beyond that, it's not there. There's nothing beyond that. So from negative 5, and then it goes up. So the y values are going up. And it's going to keep gradually going up as the graph continues. So we can say negative 5 to infinity. Or we can say negative 5 is less than or equal to y is less than infinity. Notice that we used square brackets here because the point 0, negative 5 is included on the graph. There's an actual point there, and then infinity always gets a round parentheses. So then let's try number 3. So number 3 is a cube root. So I'm going to start a new page, but you can use the same one if you want. So cube root is right here. So you're going to press Control and then the exponent button, and it will give you a place to put your root. So 3. Oh, notice that one has a times 3 in front of it, so don't forget to do that, like I almost forgot. And then x minus 4. And make sure x minus 4 is inside the radical symbol. Press enter. And there's our function. Now cube root functions, as you know from your parent function foldable, keep going forever. And the positive direction and the negative direction. So if we're looking at our domain, it's really going to keep going out here forever. So negative infinity to positive infinity. So we can say negative infinity to positive infinity, or we can say all real numbers. In fact, you know what? Let's make that proper. X is an element of the real numbers. And then the y's are the same way. So they're gradually going up this way and gradually going down that way. They keep going forever. So the range is going to be negative infinity to positive infinity, or you can say y is an element of the real numbers. So let's go look at a log. It's okay, number 9. Again, I'm going to start a new page so it's nice and clean for you, but you could keep using the same graph page if you wanted. So I have log of x plus 1 and then plus 4. And I know we've kind of talked about how if you are not sure what log is yet, don't worry about it. We do it in April, I believe. So Control and then 10 to the x is your log button. Now notice there's no subscript on this problem, so you can just leave that blank. We'll talk about later what that means. So x plus 1, and then get out of the parentheses to do plus 4. Press enter, and there's your graph. Now, this does keep going down forever. The calculator stops because the calculator only has so many decimal places, and at some point it just can't do the calculations anymore. So in a calculator, you're going to see a log stop, but just know that it keeps going down. So I'm pulling up trace again so I can see. So if I start with my domain, notice 0 is okay for an x value, and I can keep going to the right so my x's can keep getting bigger. Let's see how small I can go. Ooh, okay. So negative 1.2 is already undefined. So let's try negative 1. And you can just start typing whatever value you want to test. Oh, so negative 1 is undefined. So my x values can go from negative 1 to infinity, but not including negative 1. So I'm going to write that two ways. So I can go negative 1 with a round parentheses to infinity, or I can write negative 1 is less than x is less than infinity. And then the y's, so the y's actually keep going down and down forever, even though it looks like the graph stops. So the y's keep getting lower, and then they gradually, slowly grow in this direction. So the y's go from negative infinity to eventually positive infinity. So there's the two ways that you can write that. For the absolute value, I'm just going to show you how to type that in. So I'm going to start a new page. So absolute value, there's two ways to type it in. You can type, sorry, my camera is in the way of my calculator. You can type A, B, S, parentheses, and then this one is x plus 4. I'm just going to put an x there right now. So you can type it as ABS for absolute value, or if you go into this menu, it's kind of a template menu, press that, and it's right here. So that's two ways to get the absolute value symbols. So let's go. So go to the next page, and you'll notice you have this diagram. These are number sets. So these are number sets. Mostly in this class, what we deal with are all the real numbers, all on this side. There is a time in Unit 4, so November, maybe December, that we do some imaginary numbers. So we're not worried about imaginary numbers right now, though. We're just looking at real numbers, but they're there for you. So these are the different types of real numbers. So we have natural numbers, which are just like 1, 2, 3, 4, 5, and so on, counting numbers. Whole numbers, which are counting numbers and 0. Integers, which are your whole numbers plus their opposites. So no fractions or decimals in here. And finally, we get to the rational real numbers, which includes fractions, certain decimals, so terminating decimals and repeating decimals. So anytime you're dealing with money, you're dealing with a rational number. That's going to be important. And then real numbers are everything else that you've used so far in school, but is not one of these. So square root of 2, pi, e, you'll learn about later this year. Any decimal that does not repeat and does not terminate. So we're going to use this on the next page. Turn to the next page. Now, on this page, you're still doing domain and range, but it's more like practical-ish domain and range. You're going to look at these certain problems and say what type of numbers you would use to model it. So a plumber charges $96 an hour for making house calls to do plumbing work. What are the domain and range of this function? So domain has to do with the hours worked, and the range has to do with the bill or the price. So hours, most of the time a plumber is going to round to the nearest hour. So we're talking numbers like well, not 0 hours. So 1 hour, because plumber's not gonna, they're not gonna call a plumber if you have 0 hours of work, you know what I mean? So 1 hour, 2 hours, 3 hours, 4 hours, and so on. So what matches that? Well, let's look at our number sets. 1, 2, 3, 4. Oh, so your natural numbers, your accounting numbers. So you would say domain, natural numbers. And then the bill, so the bill is going to be in dollars. Now it's $96 an hour, but it's probably plus tax or something like that. So money is going to be a rational real number, and you can just say rational number. But more than that, positive rational numbers, because you're not going to have a negative plumber bill. We wish we did, but we don't. So positive rational numbers. And just as a little tidbit, you know how real numbers have their own symbol? Natural numbers do too. It's an N with an extra stick. And the rational numbers are actually a Q. A Q with a little extra bolding, like a bold Q. Q for quotient. So let's do one more. It's number 5. The air pressure exerted on a person depends on their distance above or below sea level. What are the domain and range on this function? So air pressure is going to be our range. Air pressure depends on altitude. So altitude is domain, air pressure is range. So altitude can be above or below sea level, so we're looking at positive and negative numbers. And altitude can be a decimal. It can be half a foot above sea level. Maybe I'm standing on a rock at the beach. I don't know. But you can go ahead and put all real numbers for this. Depending on what unit you're measuring in, it could be almost anything, really. And air pressure is not going to be negative if you were standing on the earth somewhere. It's going to be a positive number. So we can say positive real numbers.